Our next session, the BioHacking Village, celebrates global health ingenuity arising from maker communities with the dynamic perspective of emerging biology, technology, and human enhancement. Whether your interest lies in security, technology, engineering, devices, or fabrication, BHV welcomes unapologetical, enthusiastic innovators. Up first is Nathan Parker, Project Manager at Helpful Engineering.
Hello and welcome to my talk on supply chain mesh networks, open source disaster resilience in a world on fire. My name is Nathan Parker and it's a pleasure to be here today. I want to tell you a story. In March of 2020, a small team of engineers and makers in Colorado transitioned their shop into a prototyping lab. They spent the next couple months developing open source designs for critical medical supplies and devices that were suddenly impossible to find enough of. They worked closely with local hospitals and turned out thousands of units of their new design over the coming months and helped a lot of doctors and nurses stay safe while they worked. After almost 6 months, the group disbanded to find paying work. So is this a feel-good, heartwarming story? Not really. Not because these makers did anything wrong. I know hundreds just like them with the same story to tell all over the world, and they're some of the smartest and most compassionate people I know. The reason it is actually a sad story is this. This is not a brief interruption in service, and these mad sprints of intense effort are noble, but also wildly unsustainable, uncoordinated, and underfunded. They, along with thousands of others like them around the world, spend a huge portion of their time, money, energy, health, and labor on simply creating the systems needed to work with their communities and each other. They reinvent wheels, lose valuable data in silos, and even if the design they come up with is the best, the only way you'd know about it is to follow them on Facebook. This clearly doesn't work. Let me put it this way. If you believe that this whole crisis and its cascading global systems failures have been a fluke, a once-in-a-lifetime event after which we can safely resume another 100 years of efficient global supply chains providing for our comfort and security without a hiccup, then I have a cure for COVID to tell you as well. COVID has shown us many of the ways that the global supply chain will fail us when we need it most, and this is by design. Supply chain is a system optimized for efficiency, not resilience. It is optimized for profit, not human and environmental well-being. It has split the world into people who make things they cannot afford to buy and people who buy things they don't know how to make. It is a great way for a few people to make a ton of money, but a terrible way to ensure the survival and well-being of people in general. The system that's been very well suited to deliver goods efficiently in a world where the climate is in a steady state, cost of oil is stable, and geopolitics are predictable. This is not a world any of us live in anymore, and there's no compelling reason to believe that we will again in our lifetimes. So perhaps what we can do is take a closer look at the things that have worked when nothing else has. The systems created on the fly that outperformed federal agencies in the critical first months of disaster response and see what they have to teach us. When supply networks break down in an area or have never served it particularly well in the first place, what you tend to see appear are peer-to-peer networks or mesh networks, which connect local nodes of suppliers, manufacturers, distributors, and customers to each other in a decentralized way. Throughout the COVID crisis, we've seen these types of networks popping up all over the world where local manufacturing firms, maker spaces, and ad hoc groups of engineers have self-organized to create new open source designs for critical supplies and instantiated peer-to-peer localized supply chains to fabricate them. This picture is from a group that a friend of mine spun up in Oakland, California that received donations of several tons of PET sheets and turned them into tens of thousands of face shields and distributed them to hundreds of thousands of people, or just tens of thousands of people all over the Bay Area. Through one such network, open source medical supplies based in the US, we can confirm more than 16.3 million articles of open source medical supplies were fabricated and delivered, including masks, face shields, gowns, oxygen concentrators, ventilators, and so on, since the end of March. In India, the M19 collective organized around Makers Asylum and built a coalition of 42 partner organizations across the entire country. They produced over 1 million face shields, many of which were exported as donations to places as far away as Kenya and Tennessee. But when Mumbai saw a surge in cases, they had to refocus on providing for those close by. At the height of its operation, the asylum alone received about 200 calls a day from labs and hospitals requesting supplies, and leaned on the full-time dedication to communication staff as the main areas that they sunk their time and energy into. At one point, the roughly 100 leadership staff for this organization were coordinating using a giant WhatsApp group, though each lab managed their own volunteer group internally. Again, this is both wonderful work, noble effort, amazing for something that grew out of nothing. Also, if you've ever tried to organize anything on a giant WhatsApp group, wildly unsustainable. Which leads me to the large print giveth and the small print taketh away. This type of decentralized network approach has shown an enormous amount of promise in the flexibility of its productive capacity, the speed with which it can adapt to changing circumstances, the resilience it has as a network, and the resilience it imparts to the communities that make it up. However, these networks suffer from many challenges that haven't yet been solved. And this makes the majority of these efforts a series of unsustainable sprints rather than a sustainable feature of a society desperately in need of better ways to adapt for the long haul of climate change. These challenges include a great deal of reinventing of wheels, as these self-organized groups have to create not only their own operational structure, but their digital infrastructure from scratch every time. These spontaneous communities spend a huge amount of their available energy, talent, and resources just figuring out how to work with each other, how to pull in a signal from their community about what they need, how to turn that into the thing that they need and get it out to them. I've watched this happen so many times, and the number of people who have come in with excitement and energy to make this happen and burnt out 2-3 months later is tragic. Moreover, I cannot tell you how many hackathons I have seen where well-funded groups of engineers get together to create a kind of functioning prototype that's very exciting that already exists dozens of other places. It is literally easier to create something new from scratch that only kind of works than it is to find the thing that does the exact same thing that's already out there, that's been designed, and just improve on it. All right, anyway. Wheel reinvention. Like I said, most of the solutions that are created in these kind of scenarios are lost in data silos and lakes, disappear when the organizations run out of funding, burn out their volunteers, or disband after the immediate crisis is resolved, and then it all has to be reimagined and rebuilt all over again. Most of the conversations that we're having right now about COVID are the exact same conversations we had 6 years ago about Ebola, and we're going to have them again the next time if we don't figure out a better system for this. This particular crisis is far from over, and the next one is already here. It's important to note here that the difficulty of this challenge only goes up. There is no version of our next 50 years where things get easier. Disasters are not polite, and they do not wait their turn. So we need to keep this in mind as we face this choice. Either we can treat the response of makers and ad hoc peer-to-peer supply chains as a novelty while we wait for things to return to normal, or we can take them seriously. To take them seriously means we need to figure out how to improve on them, support them, integrate them into our society, and scale them globally. The good news is this. Systems we've been building are an example of a well-known type of network called a mesh network, widely known for its resilience and flexibility. One example you've probably heard of is the Tor network. It's not a perfect metaphor, but if you're looking for design principles for building a rock-solid mesh network, you could do a lot worse than to look here. Okay, so what does this actually mean? When we say peer-to-peer supply chains are like a mesh network, what does that actually mean? Or would it look like if this thing existed, and how do we think about something that's so abstract? So in the case of a Tor network or this supply chain mesh network, all we're doing is tracing a signal through a network. In information networks like Tor, the signal is purely digital, and it does more or less what we're used to doing. In the case of a supply network, the main inbound signal that we care about is a request, something along the lines of, we need X amount of objects in this location. It depends on the existence of a common open library of possible objects, but more to that in a minute. The demand signal enters the network and is routed based on its header metadata, just like anything else. But in this case, that metadata is a little more interesting. This metadata is like what tools are required to fabricate this thing, what materials are needed in what quantity per unit, what manufacturing process is needed to produce these at a given scale, where is the next node that it's going to, what's the closest qualifying node that can produce these items. So like in a Tor network, every node only knows where its packet goes to next, and so none is aware of the entire chain, even though the packet itself must have a record of its own route to validate things like chain of provenance, if you want to know that the thing that you ordered is actually the thing that was made and so on. But again, all of these are fairly well-solved problems just in a parallel domain. As the system routes your request through the nodes, a node is chosen for its capacity and availability to produce the items requested somewhere close to the exit node where the things actually need to be. When the signal arrives at the relay node, in this case, that's where it's going to be fabricated. The information payload of the signal, which is your design and your instructions, your bill of materials and quantities and so on, is converted into physical objects using the tools and local labor at that space. From there, it goes back into the system for the final leg of its journey, where the digital network merges with the logistics network. Depending on circumstances, this can be anything from just dropping it off with UPS, sending it by drone, or walking it over by hand. But the goal is to keep production as close as possible to need. The fact that we can fabricate, any amount of anything in a factory 3,000 miles away doesn't do you any good most of the time, especially as things get more and more crisis heavy. So the term node is still fairly abstract. What does this actually look like in reality? Most of the production nodes that we've seen in cases that I talked about above are maker spaces, fab labs, university prototyping labs. This is obviously the best we can work with in terms of existing infrastructure, but I want to take this idea a step further and strip away some of the complexity that comes from this wildly heterogeneous mix of spaces. If we boil the spaces down to their essential properties and remove the constraints that they have to be big, expensive, and stationary, then some interesting paths open up to us. And I want to talk about one of these here with you really quick before we wrap up. So for those who haven't spent any time in a fab lab, you may or may not know that over the past decade, digital fabrication technologies have become orders of magnitude more effective, accessible, and affordable. Out of the existing libraries of hundreds of open source humanitarian and medical supplies, every single one can be made with some combination of these tools, and all of these tools can fit in some combination in a container. And when you have the robust database of open hardware designs and tools required to fabricate them, then you can start provisioning and deploying containerized microfactories automatically based on the needs of a particular time and place. Technology like Docker enabled this kind of rapid environment configuration and containerization in software development and changed the entire industry. Perhaps we can do so here as well. So to bring it all together, let's imagine a scenario in which we get another combination of disasters, something big enough to disrupt the supply chain for an unknown length of time. Again, this should be the default expectation for all of us from this point on. The Anthropocene is just getting warmed up. So let's say, for example, we have a cell of superstorms completely disrupting transatlantic shipping. Oil supplies are fluctuating wildly, so the cost of shipping goods long distances is now unpredictable. And wildfires are spreading and cities start to burn. Does sound familiar? Suddenly you have thousands of people needing emergency shelter that can last them anywhere from 6 months to years. You need medical supplies, quite possibly water purification, depending on what's happened to the groundwater and so on. Good news is, open and accessible designs for all these things exist, but how do we get them to where they need to be? Now, say you have communities in and around the affected regions who have actually invested in this technology, who have these containerized microfactories either sitting idle or being used for education or workforce development in the downtime, and they can be mobilized immediately when the crisis hits. You can deploy them to, a parking lot. You can deploy them to a warehouse. You can deploy them to wherever a centralized place is. And now you have, designs for, flat pack emergency housing you can make with plywood and a CNC machine. You have designs for water purification systems that you can make with, charcoal, sand, gravel, and a bunch of wood and carpentry tools that will purify water for hundreds of people at a time, and so on. You can start building micro wind turbines to bring in power while you're waiting, so on. So imagine we have the supply chain mesh network in place. Every node is active and unaware. And think about the groups that we talked about earlier that had spent months and months ramping on to be able to meet these needs, but in this very short-term sprint kind of way. Now, no more are they needing to develop new prototypes from scratch when all of the open humanitarian designs are already ready to be deployed. And we're spending months of precious time and hundreds of volunteer hours creating new systems from scratch to connect and coordinate when you can onboard and be in the system up and running in days. Systems that are now held together by volunteers and spreadsheets, making up the shortfall where governments and corporations are failing, keeping their families and communities alive, can instead pour their whole effort into doing the work that matters most when it comes to resilience, making what you need to survive when and where you need it. As always, there is fine print, and a reason this kind of system doesn't already exist. There's a number of tools and specifications that need to exist first, or you may as well try to recreate the internet without having HTTP or HTML. The open hardware ecosystem is about a decade behind the software ecosystem, but this is changing rapidly. By looking into the ways that software and network design have evolved over the past decade, we can accelerate the process of catching up. So all these tools on the list are well-solved problems, things we take for granted now with all our DevOps tools, pipeline automation, version control, and so on. We just need to adapt these tools and the principles of mesh network design to the open supply chains that are already here and will continue to crop up as part of the response to our litany of impending disasters. In so doing, I believe we can all be better prepared for what lies ahead. Here is a partial list of the organizations working on solving this problem. We all remain committed to supporting, coordinating, and amplifying the efforts of the makers and engineers around the world, showing up in a crisis to help save lives. We know this is only the beginning, and we must all do what we can to work together if we are to make it through this century at all. Thank you for joining me for this talk. I hope you enjoyed it. I hope you learned something, and please feel free to reach out to me if this sort of thing interests you. Thank you.